So the first thing is a couple of or several key terms, right? Vocabulary. A lot of them might sound familiar because you've seen them in another class, right? So if an angle, so the blue part is the angle, right? The mouth, the opening of the mouth. When we're talking about an angle, it's the opening. It's not the distance, it's the opening, right? So the blue opening for the first one is less than 90, right? So if it's less than 90, it's acute angle. If it's exactly 90, it's a right angle. If it's bigger than 90 but less than 180, it's called an obtuse angle. If it's exactly 180, it's called a straight angle. That's off a straight line. The reflexive is one maybe I've seen before. If it's bigger than 180, it's a reflexive. It's called a reflex angle, not reflexive, reflex angle. And if it goes all the way around, full rotation, it's called a 360. Okay. Okay. So trig. When we're talking about trigonometry, it's the study of these guys here. What is your shape called? Triangle. It's the study of triangles, right? Triangles have two parts. It has sides. Sides. How many sides does it have? Three, right? And then it has angles. How many angles is that? Three angles, right? That's why it's called a triangle, right? Three angles, three sides. That's all trig is. Trig is just looking at the angles and looking at the sides of a triangle. Okay. Um, Sometimes it has a right angle, right? Sometimes it has a right angle. That's called a right triangle. Okay. That's all it is. Okay. So when you see the word trigonometry, it sounds really intimidating, but no, it's just triangles. When you see trigonometry, just think triangles. That's all. Okay. Okay. So when we're talking about angles, so today we're going to focus on the angle part. So when we're looking at angles, we can have positive angles and we can have negative angles. I don't know if you guys have seen negative angles before. We're going to see those today. So how do we get a negative angle? It all depends on direction. Which direction are you going? Okay. So the first one, if I start this way, this opening is a positive angle. I can move it this way. It just depends on how open it is, right? It's a positive angle because it starts up. The opposite is starts down. So if it starts down, it's a negative angle. Okay. So this angle here wouldn't be a positive angle, it would be a negative angle. So what makes a negative angle? It's direction. Which direction did you start? If you started going down and then worked your way around like that, that's a negative angle. If you went the opposite direction, that's a positive angle. That's the only difference. Okay. So there's two ways that we measure angles. You guys up to this point have been using number one, degrees, right? How many degrees does every triangle have? 180, right? 180. If I were to add up this opening, and this opening, it would equal 180. Otherwise, it's not a triangle. It's another shape. Okay? We're going to learn today about something called radians. I'll explain what they are later, but we're going to work with something called radians. It's similar to degrees. It's just a different system. Okay? All right. I have some examples here of positive angles and negative angles. There's a typo. So the bottom angles, the bottom negative angles, it should be negative 120 degrees, negative 210 degrees, negative 315. For some reason, when I printed it out, it put the wrong angles in. So change those. The top's fine, but the bottom is the angle that they create is wrong for some reason. I don't know why. Okay. Negative 120 degrees, negative 210 degrees, negative 315 degrees. Okay. So the top are examples of positive angles. On mine, they're blue. I know on yours, they're not blue, but you can see it on mine. Blue, so the first one is a 130-degree opening. Okay. The next one goes past 180. 210-degree opening. And the last one goes almost to 360. It's a 300-degree opening. Positive angles because they start by going up. The bottom starts by going down. So this one's a negative 120-degree opening. The next one is a negative 210. And the last one is a negative 315. Okay, they still have openings, they're just in the different direction. So that's why they're positive. The tops are positive, the bottoms are negative. All right. Because you're going to see negative angles, and you're like, whoa, where are negative angles? Just goes in the opposite direction. Okay. The next thing, turn it over or open it up. We have 4 quadrants, right? We have 4 quadrants. Top right is quadrant 1. Top left is quadrant 2. Bottom left, quadrant 3. Bottom right, quadrant 4. When we're talking about reference angles, you're going to be hearing reference angles a lot. What is a reference angle? Well, it depends on what quadrant you're in. Let's start with quadrant number 1, top right. Whatever your actual angle is, it's going to be the same as the reference angle. Okay, so the reference angle is the red angle. The kind of the green on mine is the actual angle. Okay. If we're in quadrant 2, what do you notice about the 2 angles?
If it's in quadrant 2, the reference angle is whatever or what the angle itself does not take.
Up to? You're right, keep going. Up to?
Degree 180.
There you go. Whatever's missing, 180, right? If it's in quadrant 2, whatever's missing to get to 180. Okay? So whatever is the missing part, that's going to be the reference. That's going to be the reference angle. Quadrant 3. Kind of like quadrant 2, but we go back. So this one, we went past 180. This one, we went past 180, right? So whatever it is to get back to 180, how much is it to get back to 180? That's the reference angle. Okay? And then the last one. We're almost to 360. Well, how much would it take to get to 360? That's the reference angle. What do you have left in your trip? What opening do you have left that would get you to 360? Okay, that's how you find the reference angle. Okay, so we're going to do a couple examples. Let's do, so the first, when I do these, so example number 1, let's do example number 1. They want a reference angle for 210 degrees. First thing I'm going to do is I'm going to draw a picture. Doesn't have to be a perfect picture, but a picture that will give me what's going on. So 220. Which quadrant is 220 going to be in? Is it going to finish? Quadrant 3, right? It's going to go past 90, right? This guy is 90. The first marker it passes is 90, then 180, and then 270, and then 360, which is the same as the starting point, right? Right? It's like a Monopoly table, right? The starting point is the exact same as the ending point, right? And then you just start over again when you cross it. It's like the same thing. Okay? So 120 is past 90, past 180, and somewhere in between 180 and 270. Which one is it closer to, 180 or 270? Barely 180. Yeah, it's kind of in the middle, but it's a little bit closer to 180. So I'm going to draw that right now. So this is the angle it creates, the blue angle. So the question is, what is the reference angle for 220? Well, it's in quadrant 3. We just said that, right? 220 degrees. We just said it's in quadrant 3. So quadrant 3 says whatever it takes to get back to 180. So how much is it going to be to get back to 180? 40 degrees, right? 40 degrees to get back to 180. So guess what reference angle is going to be? 40 degrees. Okay. Or you can just subtract it from 180. That's the same thing, right? That's 220 minus 180. That'll get me back to 180. Okay. Let's do example number 2. This one's a negative angle. Here's kind of a trick question. It's not really a trick question, but you got to think about it. What quadrant is negative 156 going to be in?
3.
It's going to go backwards, right? So which quadrant is going to be in?
3.
3. It's going to be in quadrant 3 again. How do you know? Well, if I'm going this way, it's negative angles. So the first marker I hit isn't going to be 270. It's going to be negative 90 degrees. And then this is not going to be a positive 180. It's going to be negative 180 and negative 270 and negative 360, right? Because I'm going in that direction. So negative 156 goes past this and almost comes to this. So negative 156 is right here, this opening there. Okay. Well, quadrant 3. If we're in quadrant 3, the reference angle just needs to get back to 180. So how many degrees is it to get back to 180? How many is it to get back to 180?
336.
No, I'm almost there. See, I'm almost there. I'm almost at 180. Negative 24. It's actually going to be negative 24. Negative 24 degrees. I'm almost there. I just got a little bit left to go. I went negative 156. I just got to go a little bit more and I'm done. Okay. All right. So do example 3 on your own now. Do example number 3 on your own. Which quadrant is it in? And then use your notes. That's the first thing. So this one is positive. So it's going to start up. And it doesn't even make it to 90. It barely goes up anything. It's a small angle. It goes up and it stops like right about there. It's closer to 0 than it is 90. Right? That's 18 right here. So if it's in the first quadrant, reference angle is going to be exactly the same. Exactly the same, because that's what it says in my notes. It's going to be exactly the same. So the 18 degrees. In quadrant 1, whatever the angle is, the reference angle is going to be the same. In quadrant 2, it's going to be how much to get back to 180 or to get to 180. In quadrant 3, how much is it to get back to 180? In quadrant 4, how much is it to get all the way around to get to 360? Reference angle? Yeah, we had one there. So at 156, example number 3. Nope, because it's positive. If the angle is positive, the reference angle is always going to be positive because it's this opening. If it was a negative opening, negative 18 is down here. Negative 18 is like down here. That's positive because it went up. Okay. All right. The last part of the notes is this thing called radians. Changing them, converting between degrees and radians. Okay, so degrees and radians. They're just two separate systems of measurement. That's it. It's like in this country, we use Fahrenheit. for degrees, right? It's 70 degrees, 63 degrees Fahrenheit right now outside. We are the only country in the world that uses Fahrenheit. Everybody else, you could get a dart and throw it at any country that's not the United States, and they don't use Fahrenheit. They might know what it is, but they don't use it. They use something called Celsius. Celsius, right? It's the same number. It's not like they would say it's colder or hotter. It's the same number. It just means different, right? Like 32 degrees Fahrenheit is 0 degrees Celsius. It's just what we use a different system, right? It's like degrees and radians. It's just a different system. It means the same thing, okay? Another example, you get in your car. You get in your car and drive, all right? If you get in your car and drive, you have a little thing in your car that says how fast you're going, right? Speedometer, 60 miles an hour, 65 miles an hour, 30 miles an hour, right? We're the only country in the world that has miles per hour. Do you know what every other country has? Some of you that have been to other countries? Kilometers per hour, yeah. It's called kmph, kilometers per hour. Because I think like 60 miles an hour is like 100 kilometers per hour. There's a conversion rate, right? It's just like pounds, right? Pounds. I'm not sure if anyone else uses pounds for weight. I think we're the only country that uses pounds for weight. What does every other country use? Kilos, kilograms, right? Kilograms, right? If you go to Europe or you go to Mexico or you go to Central America or South America, Asia, Africa, they use kilograms. So if you tell them I weigh 100 and blah 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 pounds, they're gonna be like, what? What? They don't know what that means, right? And then actually, I think actually Britain, England. I don't think no, not England. I think some of like the Russian countries, they don't use kilograms or pounds. You know what they use? Something called stones. Stones, right? They use stones. So it's like they say, you weigh 20 stones. It goes back to the old times when they actually used stones to measure, to balance out your weight. So that's what they say. When they're measuring weight, they say by stones. I'm not making it up, trust me. So like the reason I learned about it is because I think I was watching it was like a UFC fight or something like that. And then they always say the weight, right? They always say this guy weighs this guy weighs this, or this girl weighs this girl weighs this. And it wasn't the United States, it was in Russia, I think, or one of the Russian countries. And then they said this person weighs 15 stones, this person weighs 16 and a half stones. And I'm like, I can't do anything with that. I can't do anything with that. So I had to look it up. I think a stone is like 20-ish pounds or something like that, 15 pounds, something like that. But again, they use different conversion rates, right? It's the same thing though. Up to now, up to this point, you guys, from the time you started doing you guys started with degrees, right? All you guys have done is degrees. So from not kindergarten, but elementary school to junior high, math 1, math 2, everything's degrees. After today, we'll still use degrees, but the main one we're going to use is radians. Okay, the radians. Okay, so to do that, we have a couple of formulas to help us. So when we want to know what is radians, if the question is, I need the radians, you're going to use the top one. If the question is, what are the degrees? I need to know degrees. You're going to use the bottom one. It just depends on what is the question. Okay? So we're going to do a couple examples together. We're going to do a lot of practice with this. All right, so let's go to the other side. Should be 4A, not 1, and 4B. 4A and 4B. Okay? 80 degrees. 80 degrees is almost 90 degrees, right? It's an acute angle, but it's on the bigger side because once it goes past 90, it's obtuse, right? So we want to convert that to radians. Radians. Okay? So we don't know radians. Radians is my question mark here, right? So if radians is my question mark, I'm going to use the top one. It's written on the board too. 180, or sorry, pi over 180 degrees times, and then whatever the degrees is. Okay, so pi over 180 degrees. We'll talk about that. Yeah, we'll talk about what pi is and why don't we write it like that. Yeah. Times degrees. Right. Well, 80 is over 1, so I can make it a... How do we multiply fractions? Straight across. Yeah, not cross like x's, but cross, straight across, right? So if I straight across, I would go 180 degrees pi over 180 degrees, because 180 times 1 is just 180. What's the same on top that it is on bottom that I can cancel out? The degrees. Yeah, if they both have degrees and I'm dividing them, they both cancel out. Now, the last step, reduce the fraction. What's the biggest number that can divide 80, go into 80, and 180 evenly? 10 for sure. Yeah, how do we know what's the rule? How do we know 10 for sure? Because they both end in 0. If they both end in 0, you can always divide them by 10. So if I divide the top by 10, I get 8 pi. If I divide the bottom by 10, I get 18. I think I can still reduce them. Divide them by 2 again, or divide them by 2 this time. Leave it with pi. Great question. Why do we not multiply times 3.14, whatever pi is, right? Why do we not multiply? The reason is because, does pi ever end? No, it doesn't end, right? Pi goes on forever and ever and ever. It still hasn't ended, right? So if we write 3.14 there, we're rounding it. I don't want you to round. I want the exact answer. Okay? This is the exact answer. Always give me the exact answer unless they say in the directions, round. Okay? Okay, you guys have had pi before, or you guys not had pi before, but you heard of pi, right? Pi, this guy right here, the two lines with the squiggly line on top. Does anyone know where pi comes from, or what it is, or where does it come from? Close, diameter of a circle. So pi, where did pi come from? Well, it came from the Greeks. The Greek, back a long time ago, the Greeks said, how do I make a perfect circle? How do I draw a perfect circle or create a perfect circle, right? If I'm building a fire pit in my backyard, I want a perfect circle. So what's the way to create a perfect circle? Well, to get it like exactly perfect, it is, and because pi hasn't ended, but the way to do it is take a circle, find its circumference. Circumference is all the way around it. So a string or a rope, take a rope, get all the way around a circle, measure that string or that rope. Okay, get that number. And then find the diameter. Diameter is a line that goes from edge to edge, passes through the center. Get that number. If you divide those two numbers in your calculator and you get 3.1415 forever and ever and ever, that's a perfect circle. That's the perfect circle. The closer you can come to that number, the more perfect. That's a bad word because how do you have more perfect? But the closer you get to a perfect circle, right? So if you have a circle and the circumference is like the perimeter, like how far is it all the way around the circle. The diameter is edge to edge, cuts through the middle, has to cut through the middle. If you divide those two numbers and it's a perfect circle, you will get pi. That's how we get pi. Okay? And kind of the reason why pi never ends is because you can't, nothing's perfect. Nothing's perfect in this world, right? We can come close to perfection, but there's no such thing as like a perfect anything. So that's why pi never ends, because you can't, you know, whenever the day we can make a perfect circle, the day pi will end. Okay. What's that? You'll spend your whole lifetime trying to do a perfect circle. Yeah. Just come as close as you can to a perfect circle. Okay. All right. So I want you to do number 2 right now. Do number 2. Convert 125 degrees to radians. So since the question mark is radians, we're going to use 180 over, or pi over 180 times the degrees. So multiply straight across. I got degrees on top and degrees on bottom, so the degrees go away. Then I have 125 pi over 180. I think I can divide them by 5. I know I can divide them by 5. I think that's the biggest. So if I divide 5 into 125, I get 25 pi. And if I divide 5 into 180, I think I get 36. 25 over 36. Can I reduce that anymore? I don't think I can. I think that's as far as I can reduce it. Done. So 125 is the same thing as 25 pi over 36 radians. Okay. On your calculators, if you have a regular calculator, you'll have a DEG button, or not a button, but on the calculator, it'll say DEG or RAD. If you have a calculator. If you have a phone calculator, it doesn't do this, but it'll say like you'll have DEG or RAD. Most of the time, it's in DEG mode, degrees mode. But if you're in radians mode, you got to change the mode. Okay, that's what those mean. Sometimes you'll see those on a regular calculator, on a scientific calculator, I should say. That's what they mean. Okay. All right, so now we're going the opposite direction. So now I don't know what the degrees are. So if I don't know what the degrees are, I'm going to use the bottom. So this time it's 180 over pi. 180 over pi. So 180 degrees over pi times, they give me radians this time, so it's 13 pi over 12. Same exact thing, multiply straight across. So 180 degrees times 13 pi, I get 2,340 degrees pi. And on the bottom, I get 12 pi. What can cancel out this time? Pi's, yeah, not the degrees. Degrees stay this time. So I have 2,340 degrees divided by 12. And you get 195 degrees. Okay. All right, I want you to try number 6. Try number 6 on your own. Give you a few. Okay, so since we need to find degrees, we're going to use 180 degrees over pi. I'm going to put my radians in there, and then I'm going to multiply straight across. So 2 times 180 is 360 degrees pi over 3 pi. Pi's cancel out. I get 360 degrees divided by 3, and you get 120 degrees. That one's a popular one. 2 pi over 3 is very popular. That's the one you'll see. 13 pi over 12. You won't really see that one a lot, but 2 pi over 3 is very common, a very common angle, 120 in quadrant 2. Okay. All right, last one in your notes. I'm going to post this on Google Classroom. Yeah, so just like I always do, so you don't have to take pictures, or if you miss something, just go back. I'm going to post it right after this class. Okay. The last one. Look at the last one. What's the question mark? Is the question mark for degrees, or is the question mark for radians? Degrees, right? The question mark is degrees. So I'm going to use the bottom one again. 180 degrees over pi, right? But what's different about these radians than in the other ones?
There's no fraction.
There's no fraction. Good. That's one reason. What's another one? We have to round. It has no pi, no fraction, pi. We have to round, and what other thing? It's negative, right? It doesn't matter if it doesn't have those things. Treat it like if it did have those things. So if it did have those things, we would move it down here. Treat it that way. It looks different. We treat it the same. Okay. So we multiply straight across. We get negative 540 degrees. The bottom, we get pi, which is pi over 1. Pi times 1, which is a 1 pi. Now the pi's don't cancel out. The degrees don't cancel out. But I need it in degrees, right? So this is the only time you're going to divide by pi. You're going to use 3.14 number, right? So when you go to your calculator, you're going to say negative 540 divided by pi. Use the pi button. Don't use 3.14 because that's a rounded number. Pi is still a rounded number, but it's a lot closer to what it actually is. That's what it is there. It said round. Round to the nearest tenth. Which number is in the tenths position? 8. Good. Which 8? The first 8 or the second 8? It's actually the first 8. This is the tenths. The first 8 is in the tenths. The second 8 is in the hundredths. Then the 7 is in the thousandth, 10,000th. Okay. There is no oneth. You're looking at the other side. One, that's the ones with an S. Tens, hundreds over here. When you're talking about the other side, it starts with the tenths. Okay? Watch. Decimal places.
Did we learn about this in school?
Yeah, there's a ones. There's no oneths. It starts with tenths, hundredths, thousandths. Okay? When you're going to the right. When you're going to the left, it starts with ones. Okay? So just be careful about that. Okay? So the first 8 is the tenths. So we look behind it, and that means we raise it up or stay the same? Raise it. So it'd be negative 171.9. Degrees. Because it's in degrees. Okay. All right. Okay, so normally we do some extra practice, right? Either in your notebook or on the desk with the whiteboard marker. Today we're going to do things a little differently because this is going to help you later. So you should take out your half sheet now. You should have a half sheet that looks like that. Okay? So what we're going to do here, this is something called the unit circle. Don't worry about the name right now. We'll talk about it later. But for today, something that's going to help you in future classes and future lessons, on future tests, on future quizzes, is filling this guy out. And it's good practice for us. So each dot, you look at each dot. Each dot either has a radian measure for degrees or degree measure, right? I want you to find the other one. So the one they don't give you, I want you to find for. I'll do the first couple with you. The very first dot, 0. How many pies do you think 0 degrees is going to be? 0 pi. Yep, you guys are right. Okay. And then 360 down here. Okay, so we're going to box that because I'm done with that. I know 0 degrees is 0 pi. We're going to go in the positive direction. 30 degrees. So I know 30 degrees. I'm going to have to figure out what radians 30 degrees is. So radians, if I need to know what radians are, I need to use the top one, right? So I'm going to multiply 30 degrees. I'm going to do it over here. Times pi over 180 degrees times 30 degrees. What does that equal? What radians is that going to give me? Just like you did on the other side. Oops, no, not 30 pi, 30 degrees. Okay. Multiply straight across. You get 30 pi, or 30 degrees pi. And then you multiply the bottom straight across, and you get 180 degrees, right? Well, what's going to cancel out? Degrees are going to cancel out. Now reduce 30 over 180. What's the biggest number that divides evenly into 30 and 180? 6 will, but there's a bigger number. 30, yeah, 30 will go into both. 10 works too, but you want to try to find the biggest number. 30, if you divide the top by 30, you get 1 pi. If you divide the bottom by 30, you get positive 6. So 30 degrees is the same as pi over 6. I'm going to box that because I'm done. 30 degrees is the same as pi over 6. One's in degrees, one's in radians, but they are exactly, they're equivalent. Okay, let's do the next one together. The next one, the one above it, the next dot is pi over 4. Well, since pi over 4 is in radians, I need to find degrees. So if I need to find degrees, I'm going to use the bottom one, which is 180 degrees divided by pi. Times pi over 4. Multiply straight across. We get 180 degrees pi over 4 pi. Pi's cancel out. 4 goes into 180 45 times. So pi over 4 is the same thing as 45 degrees. Box that in. I am done with that one. Okay, so what you're going to do now is you're going to do the rest. So each one of these dots needs 2 numbers. It needs a degrees and it needs a radians. Now, I'll give you a tip. Work smarter, not harder. Don't do them all if the person next to you is doing the exact same problems. It's your notes. These are your notes. So split up the work. Either with the person next to you, I'll do the top 1 and 2 quadrants, you do the bottom 3 and 4 quadrants. Or you split it up with 3 people, 4 people. Split it up, okay? Split it up so that you're not doing the same problems.
You have to copy the work they show.
Nope.
Okay.
Nope.
So I would do.
What side do you want to be better?
I already have the next problem.
You want to split it up. Huh?